Welcome all of you in this class. Today's topic is hyperbolic function. Let me define first the hyperbolic function. The combination of e to the power x and e to the power minus x give a new function known as hyperbolic function. The hyperbolic sign is defined as hyperbolic sine x equal e to the power x minus e to the power minus x by 2. The hyperbolic cosine is defined, or cos is defined as hyperbolic cos x e to the power x plus e to the power minus x by 2. Similarly, tan hyperbolic x is sine hyperbolic x by cos hyperbolic x. Cot hyperbolic x is cos hyperbolic x by sine hyperbolic x. Cosec is 1 by sine, sec is 1 by cos, and so on. Basic identity for hyperbolic function: hyperbolic cos square x minus hyperbolic sine square x equal 1. In general, sine square x plus cos square x equal to 1. We know that. But here, hyperbolic cos square x minus hyperbolic sine square x equal 1. And hyperbolic sec square x plus hyperbolic tan square x equal to 1. So this will be little bit confusing. That will distract your previous knowledge. That's why you should deeply study this. Cot square hyperbolic x minus cosec square hyperbolic x equal to 1. Similarly, sine hyperbolic minus x equal to minus sine hyperbolic x, hyperbolic minus sine x, and cos hyperbolic cos minus x equal to cos hyperbolic x. Similarly, hyperbolic sine x plus y equal to sine hyperbolic sine x, hyperbolic cos y plus hyperbolic cos x, hyperbolic sine y. This is in same pattern. Similarly, cos a cos b plus sine a sine b. The sign is changed here. And hyperbolic sine 2x equal to hyperbolic sine x and cos hyperbolic cos x, and hyperbolic cos 2x equal hyperbolic cos square x plus hyperbolic sine square x. In the same pattern, you have to remember the formula. While studying the formula, make a trick that which one is similar and which one is different. This is in different pattern, so study this deeply. Oh, this is different. Sine minus theta is minus sine theta. Cos minus theta is no. Sine minus theta is what? Sine minus theta is theta. This is different. So you have to study that. Which are the difference? Then you have to study that deeply and differentiate them. Now, next part is derivative of hyperbolic function. Derivative of hyperbolic sine x is hyperbolic cos x. Derivative of hyperbolic cos x is hyperbolic sine x. Derivative of hyperbolic tan x is hyperbolic sec square x. Derivative of hyperbolic cot x is minus hyperbolic cosec square x, and similarly sec minus sec and tan. Similarly, this is cot, this is cosec minus cosec and cot. So you have to remember this formula. You need to check once. Now, derivative of inverse hyperbolic function. Another part is derivatives of inverse hyperbolic function. Hyperbolic sine inverse x. Derivative of hyperbolic sine inverse x is 1 over root under 1 plus x square. Similarly, cos is 1 over root under x square minus 1, where x mod is greater than 1. Hyperbolic tan inverse x is 1 upon 1 minus x square with this relation. Cot inverse is minus 1 upon x square minus 1. Sec hyperbolic sec inverse x is minus 1 over x root under 1 minus x square with this condition. And cosec hyperbolic cosec inverse x is minus 1 over root under x square plus 1. So study this formula, check this formula once, revise this formula once, and we will discuss one example over here, that is how the derivative of hyperbolic sine x is hyperbolic cos x. So let's see, d by dx of sine hyperbolic x is e to the power x minus e to the power minus x by 2. Then differentiate this, e to the power x is e to the power x, and minus e to the power minus x is minus e to the power minus x. That's why minus minus makes is plus over 2. Then e to the power x plus e to the power minus x by 2 is cos hyperbolic x. So the derivative of hyperbolic sine x is hyperbolic cos x. You have to study this. Similarly, inverse case, let's see what is the derivative of hyperbolic sine inverse x. Hyperbolic sine inverse x. In this case, we have to suppose y is hyperbolic sine inverse x. In that case, x will be sine hyperbolic y. You know this extends. Then differentiating both sides with respect to x, the derivative of x is 1, and derivative of hyperbolic sine hy is cos hy into dy by dx. Then dy by dx equal to 1 over hyperbolic cos y equal 1 upon root under 1 plus hyperbolic sine h square as hyperbolic sine square x. Then that is sine square h y, here y, that's why that is x 1 over root under 1 plus x square, 1 over root under 1 plus x square. This is the derivative of hyperbolic sine inverse x. With this example, I have taken the example. Similarly, other you have to try. Similarly, cos, tan, cot, sec and cosec, you need to try and verify this result, whether you will get that result or not. Then only you will be familiar in this pattern. Okay, let's move to the question. Find the derivative of log hyperbolic 10x. The derivative of log hyperbolic 10x. So firstly, we have to suppose y equal to log hyperbolic 10x. Now differentiating both sides with respect to x, then we get dy by dx equal d by dx of log hyperbolic 10x. The derivative of log x is 1 by x, that's why 1 by hyperbolic 10x times, and derivative of hyperbolic 10x is hyperbolic sec square x, that's why 1 by 10 hyperbolic x, hyperbolic 10x is cos goes up, cos hyperbolic hx by sine hyperbolic x times this is 1 by hyperbolic cos square x. Then this cancel. What we obtain from this step, upper is 1, down is hyperbolic sine x and hyperbolic cos x. If we multiply numerator and denominator by 2, then this is 2 times 2 hyperbolic sine x, hyperbolic cos x is, that is hyperbolic sine 2x. 1 over hyperbolic sine 2x is 2 times this, 2 is this, 2 times hyperbolic cos 2x. This is the solution or the derivative of log hyperbolic 10x. Now you can try find the derivative of log hyperbolic sine x by a. This is for self revision. And another is find the derivative of e to the power hyperbolic sine x. This can be practiced yourself. Okay, now move to the next question. Next question, find the derivative of e to the power hyperbolic cos inverse x by a. E to the power hyperbolic cos inverse x by a. So firstly, we have to suppose this is y, and differentiating both sides with respect to x. Then there in right side, left side, that is dy by dx, derivative of e to the power hyperbolic cos inverse x by a. Derivative of e to the power cos inverse x by a with cos hyperbolic cos inverse x by a times derivative of hyperbolic cos inverse x by a by derivative of x by a times derivative of x by a dx. This is expanded from clearly I have mentioned. In the next question I will jump this, so you have to understand this expanding form. So derivative of e to the power x with respect to e to the power x, that's why it is e to the power hyperbolic cos inverse x by a, and cos inverse x by a hyperbolic cos inverse x by a is 1 over root under x square minus 1, that is x by a square minus 1. Second part is, and third x by a is the derivative of x is 1 by a itself 1 by a. Now first part is same here, x square minus a square by a square, that goes off by removing the radical sign of the denominator. A over root under x square minus a square times 1 by a cancel. Therefore the derivative of e to the power hyperbolic cos inverse x by a is e to the power cos inverse x by a times root under x square minus a square. A cancel here. This is the final answer for this question. Similarly, another question is find the derivative of hyperbolic sec tan inverse x. Hyperbolic sec tan inverse x. We have to find the derivative of hyperbolic sec tan inverse x. Firstly, let's suppose y equal to hyperbolic sec tan inverse x. Differentiating both sides with respect to x, then we get dy by dx equal derivative of this. So derivative of hyperbolic sec tan inverse x with respect to tan inverse x times derivative of tan x, here not hyperbolic, tan inverse x with respect to dx. Then the derivative of sec x is minus sec x into tan x, minus sec x into tan x. That's why minus hyperbolic sec tan inverse x times hyperbolic tan inverse x times derivative of tan inverse x is 1 by 1 plus x square. Here not hyperbolic, that's why you have to remember where h or hyperbolic is used, symbol is used, or hyperbolic function is included, where excluded, those it is tough, so you need to identify or you have to study deeply. That's why this over this is the, therefore dy by dx is upper this and denominator this is the answer. So you have to practice hyperbolic sec inverse x minus hyperbolic cos inverse x. You have to practice yourself this question. Here the solution is that. Now next question is find the derivative of arc tan sine hyperbolic x. This is also called inverse. Y equal to arc tan sine hyperbolic x equal tan inverse sine hyperbolic x. This meaning is inverse. This meaning is inverse. Now differentiating on both sides with respect to x, then we obtain dy by dx equal d by dx of tan inverse sine hyperbolic x. So the derivative of tan inverse x is 1 by tan inverse x is 1 over 1 plus x square. That's why it becomes 1 over 1 plus hyperbolic sine square x times what is the derivative of sine hyperbolic x, that is cos hyperbolic x, and 1 plus hyperbolic sine square x is hyperbolic cos square x, and this part is got 1 by cos hyperbolic x, that is sec hyperbolic x. That's why derivative of tan inverse sine hyperbolic x is sec hyperbolic x. You can practice, or you have to complete, or you have to solve, or you have to find the derivative of 2 hyperbolic tan inverse tan x by 2. Tan x by 2. This is for your self practice. Now the next question is find the derivative of x to the power hyperbolic cos x by a. x to the power cos hyperbolic x by a is the question. If some power is given, then our tradition, or we will support, we will take log, that you have to remember that part. So I have suppose y equal to x to the power hyperbolic x by a. Taking log on both side, will log y equal hyperbolic cos x by a times log x. You know that it the power goes into the coefficient and log times x. This is converted into first. Then you have to apply product property, first notion derivative second plus second notion derivative first. Yeah. Now differentiating both sides with respect to x, then we obtain derivative of log y equal derivative of these two terms. Derivative of log y is 1 by y dy by dy. I repeated many times. Yeah, 1 by y dy by dx equal first no change derivative of second, derivative of log x is 1 by x plus second no change derivative of first. Hyperbolic cos x by a is hyperbolic sine x by a times the derivative of x by a is 1 by a. You should not forget that part. Sometimes you may miss this. So finally the y goes to multiply the value of y is yes, x to the power hyperbolic cos x by a. This is y times here hyperbolic cos x by a by x plus here 1 by a times sine hyperbolic x by a, hyperbolic sine x by a times log x. In this way we find the solution of this question. Okay, now the next question is find the derivative of x to the power hyperbolic cos square x by a. This is the question. Firstly, we have to suppose this: if power is given taking log y equal hyperbolic cos square x by a times log x, not a, log x, and differentiating both sides with respect to x, then we obtain, or then we get log y is 1 by y dy by dx equal, let's see, this is first no change derivative of second, derivative of log x is 1 by x plus second no change, log x is no change, then this cos hyperbolic cos square x by a. So the derivative of cos square x, what, 2 cos x into sine x, like that, hyperbolic form. Yeah, so 2 cos hyperbolic x by a times cos hyperbolic x by a is sine hyperbolic x by a times x by a, derivative of x by a is 1 by a. So we obtain this. Then 1 by y dy by dx equal hyperbolic cos square x by a by x, first part, plus this log x by this a, 2 sine a cos a, 2 sine a cos a is sine 2a, that is sine hyperbolic 2x by a, sine hyperbolic 2x by a. Finally the value of y is x to the power hyperbolic cos square x by a, that is x to the power hyperbolic cos square x by a times this part plus this two part here, hyperbolic, we should not forget to write, log x by a times hyperbolic sine 2x by a is the answer for this question. Next interesting question is the question is find the derivative of hyperbolic sine x by a to the power x square, hyperbolic sine x by a to the power x square. So firstly we have to suppose y equal hyperbolic sine x by a to the power x square, taking log on both side, log y equal x square times log hyperbolic sine x by a. It is understood that the power goes to in coefficient here, it goes to the and here are two terms. Now differentiating both sides with respect to it, then we get, I have directly solved here, I have not expanded more because same pattern is repeated. The derivative of log y with respect to x is 1 by y dy by dx equal, first no change, derivative of this. Derivative of log x is 1 by x sine hyperbolic x by a or hyperbolic sine x by a times derivative of hyperbolic sine x by a is cos x by a. Again the derivative of x by a is 1 by a. First part is completed, plus second no change, log hyperbolic sine x by a no change, derivative of x square is 2x. Now we are at the end, means this is step. This y goes to multiply, whose value is hyperbolic sine x by a to the power x square, this times whole this term, that is x square by a, this a and this x square by a, hyperbolic cos x by a, and hyperbolic sine x by a is hyperbolic cot x by a, plus this is 2x times log hyperbolic sine x by a. This is the final answer for this question. Now moving to the next part, the question is find the derivatives of hyperbolic cos x by a to the power log x. Tentatively we are planning, or tentatively we are known now, we have to suppose y equal to hyperbolic cos x by a to the power log x. We have to take log on both sides, log y equal, this is in coefficient log x times log hyperbolic cos x by a. Differentiating both sides with respect to x, then we obtain log y derivative of 1 by y dy by dx equal log x, first no change, derivative of second log x, that is 1 by hyperbolic cos x by a times hyperbolic cos x is sine x by a times 1 by a. Yes, we know that pattern, plus first no change derivative second, plus second no change, this second part is no change, derivative of log x is 1 by x. Then this y goes to multiply, whose value is hyperbolic cos x by a to the power log x times here 1 by a log x, and hyperbolic sine x by a by hyperbolic cos x by a is hyperbolic tan x by a, plus this is 1 by x times this is log hyperbolic cos x by a. This is the answer for this question. Now another interesting question is find the derivative of hyperbolic cos x to the power hyperbolic sine inverse x. Hyperbolic cos x to the power sine hyperbolic sine inverse x. So firstly we have to suppose y equal hyperbolic cos x to the power hyperbolic sine inverse x. Taking log on both side, log y equal hyperbolic sine x times log hyperbolic cos x. Differentiating both sides with respect to, then we obtain log y is 1 by y dy by dx equal, first no change, derivative of second we already discussed, log x is 1 by x and cos hyperbolic x is sine hyperbolic x, plus second no change, that is log cos hyperbolic x no change, sine inverse x is 1 by root under 1 plus x square. Therefore dy by dx equal to y is this hyperbolic cos x to the power sine hyperbolic x sine inverse hyperbolic sine inverse x times hyperbolic sine x by hyperbolic cos x is hyperbolic tan x, and this is sine hyperbolic sine inverse x, plus this is log cos hyperbolic x over root under 1 plus x square. This is the answer in a shortcut way. Now moving to the next question. Find the derivative of hyperbolic sine x by a plus hyperbolic cos x by a to the power n x. Thus this is hyperbolic sine x by a plus hyperbolic cos x by a to the power n x. So firstly we have to suppose this n x. power is given, that's why you have to take log on both side. Log y equal nx time log hyperbolic sine x by a plus hyperbolic cos x by a. Now differentiating with respect both side with respect to x, then we get log y is 1 by y dy by dx equal n is taking out, and other terms are using to ub form to find the derivatives. For first, no change, x is no change, derivative of second. Derivative of log x is 1 by sine hyperbolic x by a plus cos hyperbolic x by a times, what is the derivative of hyperbolic sine x by a, that is hyperbolic cos x by a. Again, what is the derivative of x by a? 1 by a plus hyperbolic cos x by a is hyperbolic sine x by a times 1 by a plus first no change derivative of second, and second no change derivative of x or first is 1. This part is completed. Then dy by dx equal y times n yn times x, and if we have taken a common, 1 by a common from these two terms, and what we obtain, this hyperbolic sine x by a, hyperbolic cos by x by a, these two terms can be cancelled and the remaining term is as usual. So here y times n x by a log hyperbolic sine x by a plus cos x by a. So the last step is dy by dx n, this is y, n this is y is what, hyperbolic sine x by a plus hyperbolic cos x by a to the power n x, this is the value of y, and x by a in left part plus first part, and the second part is log hyperbolic sine x by a plus hyperbolic cos x by a. This is the last solution of this.